All right. Hey, everybody. Welcome back. We're Jim and Derek presents another episode of Everything is a Spring podcast. Derek, how you doing, buddy?
Man, I'm doing good. I got to see you earlier today in real life, so that's always icing on the cake, buddy. How are you doing?
Yeah, I'm doing great. Yeah, getting to see you earlier today was awesome. For those of you who were not aware, I was flying out to Omaha for a wedding. A cousin of mine got married. It was a lovely service. So I flew back in today, which is Sunday. So that's why our episode's a little bit late. But we're gonna get it out to you guys and not keep you waiting too long.
Oh yeah, can't keep them waiting too long. They're insatiable, Jim. They're insatiable. But no, how was your travel? Because I can't name two things in Nebraska, to be honest with you.
So the main thing in Nebraska is Omaha, from what I understand. And there's not two things else to name.
Oh,
I'm sure that's not true. I'm sure that Nebraska is a wonderful state. I did not have time to explore Omaha too much, although we did. So my sister is out there, and their little girl is super adorable. So we took her out to the park. They've got this beautiful mall kind of area, like outdoor park area down by the river. That was really beautiful, right by the downtown. We had ice cream at a wonderful place.
that sounds nice.
Called Ted and Wally's. It was called T-Dubs for short.
T-Dubs, I like that.
T-Dubs, and their claim to fame, right, is that they have the butteriest ice cream in the States, right? So it's made with like 20% buttercream, which apparently is like as high of a butter content or as high of a cream content as you can have, and it still be ice cream.
At a certain point, you're just eating butter.
Yeah, it was very, very rich, but it was really good. And they had all kinds of crazy, awesome flavors. So that was a lot of fun. But yeah, very rich ice cream. Derek, are you like a big ice cream guy?
You know, as a kid, I used to be. If I eat anything now, it's going to be like an ice cream bar of some sorts, like either the Snickers ice cream bar. I don't know if you have ever had those Haagen-Dazs ones. That's like vanilla ice cream, then it's covered with chocolate, and it has like some nuts on the outside.
I think I know what you're talking about.
Oh,
I don't think
slap
I've
hard.
had them a whole lot.
I don't eat a lot of. I've been trying to cut down on sweets, just in trying to get my weight under control and make sure I don't eat the healthiest. So if I can cut out sweets, that's just one extra level. But why?
Yeah, that's fair.
Do you like ice cream?
I do like ice cream. I actually don't like it as much as I used to.
I feel that.
Which is maybe sacrilegious, but I like it as a date. Like ice cream date is a perfect date.
That sounds
right?
perfect, you know.
Because like I don't generally want like the whole ice cream cup, right? So like splitting it is perfect.
And then you get to like have a walk around town with your best gal.
Exactly, and it's just super fun, and so that's kind of what I like ice cream for nowadays. I won't generally go get it on my own.
Yeah, same. But one more thing, we went to a new restaurant today.
We did.
You know, we didn't go to Vortex. We usually go somewhere around Atlanta area, but we were a little by the airport, south of the perimeter. And Jim finds this place. What was it? Big Dave's Cheesesteaks.
I think so.
And I'll be honest with you, Jim. I'm a big cheesesteak guy. I was so pleasantly impressed, and we learned a little bit of lore from the folks working there. The same company that makes Slutty Vegan, the woman that's the CEO of that company, Dave, is her husband.
That's awesome.
So they both just slap.
I thought it was amazing. Like the food was really good. The fries were like really crispy and well seasoned. I had the chicken Philly steak or Philly. I guess it'd be still a Philly cheesesteak.
Chicken Philly, right? Yeah,
chicken Philly. And it was amazing. I mean, it was really, really good.
And you got to go like Dave's way too. Like that's pretty much the equivalent of all the way, you know, with the peppers and the onion and the extra cheese.
Oh yeah, so much flavor.
I should have got one to go.
Good. Oh yeah, that was awesome.
We're not sponsored by them, but shout out to Big Dave. Apparently they're brand new too.
Yeah. What was it? April they started,
something like that. So I gave them a sticker.
Yeah, absolutely. Also, we have stickers now. I don't know how we're going to distribute those to our adoring fans, but we have Everything's a Spring stickers. So
yeah, these V1s are going to be the ultra limited edition, and the fact that you're probably just going to have to know us. Maybe one day we'll make some actual sellable merch.
That's fair. Yeah, let us know down in the comments or whatever if we should set up a everything's a spring sticker store.
How about this? Like,
I don't.
if we get 1,000 concurrent subscribers, right?
We'll
That's
open
fair,
up a
right?
store.
Yeah, I'll
That's fair.
make some
I feel like
merch
that's
and
fair.
put a little sauce down, and we can see if the people.
Absolutely.
At that point, someone would buy it. You know what I mean?
That's fair. I honestly just want a hat for myself.
We can make. Oh, here's the beautiful thing. I'm glad you got me the stickers because I've I know you can't see it on the podcast, but I've slapped one on my phone and I gave
Nice.
my roommate Chris a couple that he's gonna come home to after work. I'm going to slap one on my PC, but that's got to be precise because I have big glass
absolutely.
window. But no, I really like the stickers you made. That was a hell of a surprise because it makes me just want to go distribute them to everyone. But I gotta hold my cards close for now.
Oh yeah. I don't even think my family actually knows about this podcast yet.
Mine definitely know. They know I do something. They're like, he's talking to himself in there or something. No, I haven't really. I've been just kind of letting the growth go. Like the folks that follow the small amount of social media I have, I'll post it when we add an episode there. But that's really just there's folks I was going to be talking to anyway.
That's fair. Yeah, that's fair.
What about you?
Man.
I saw you said you
What a good
slapped
time.
one on your truck, right? That's pretty cool.
I did. Yeah. So I slapped one on my truck bumper, which is where I put stickers.
It's the place where stickers live.
It is.
Fun fact, this Everything's a Spring sticker is the only sticker that I actually have deployed because everything else is in the endless sticker drawer where I just can't choose where to put it.
I have sticker paralysis as well.
That's actually why.
That's actually why I don't have any tattoos, is because I have sticker paralysis, and it's even worse with something that's permanently a part of your body.
Right. I would never actually get the tattoo. Not that I want tattoos, but yeah, I'm the same way. Like, ooh, I want this, but where would I put it? And then I table that forever.
Exactly. So, well, Derek, I think that's enough preload for one day.
I could agree with you. That's pretty good.
Let's jump in to today's episode.
I'm so excited. Are we starting a new mini-series, you think?
We are. I think I've got my new mini-series that we're going to be doing for the next couple of weeks.
Ooh.
And before I reveal it, because I want to just kind of jump into the episode, as it were, Derek, I have kind of a question for you.
Right? I might have an answer.
So let me lay kind of the scene. Let me lay the groundwork for you for this question. So you're walking through the woods. It's dark. Your phone is dead.
Perfect.
And you come across a river, right? And the river is pretty fast flowing. You've never been here before, so you're not really sure, how deep it is or if there's a fordable area. How would you go about crossing this river?
Wow. How would I go about crossing this river? Do I know how wide the river is just by looking at it?
Yeah, sure. Let's say it's a manageable length, or that you have some people to help you do things, right? Like let's say that you've got, I don't know, 10 people at your disposal to help you do things.
Oh, I can't just yeet myself across the river because I would jump pretty far.
It's too big to yeet across. Let's say that the span you have to go across is, let's just say, 50 feet. Let's say it's a 50-foot span.
All right.
Maybe that's not the actual water, but that is kind of the distance between the banks.
This is dangerous, right? Because it's dark, so I can't really tell how deep it is, right?
Okay, well, let's just say the daylight comes and you can see what's going on.
Or I can swim pretty well. Do I have... I assume I don't have a life vest. I could probably... just, find a nice flat part where it's 100 yards or so, 100 feet, or maybe 100 to 300 feet of flat area where I don't see any rocks. And if I start at the up end part of that and just swim diagonally up river, upstream and across, I could probably make that.
Okay, so let's say, let's say it's wintertime.
Wow.
It's cold. It's bright outside, but it's cold.
I'm screwed.
And getting into the water would mean certain death.
Oh, so I have to engineer my way across.
You have to engineer your way across.
Yeah, okay. The goofy part of me wants to Georgia the Jungle across that bad boy, just slap some rope over a tree and hope for the best. But if I touch this river, I'm going into shock. This seems like an impossible situation. Because if I bring 10 people with me, it's just going to be 10 people going into shock instead of one.
That's fair. I'll say, what if 5 of those people were on the opposite bank?
That changes the game considerably. We could throw some rope across to each other and just make like a line, kind of, I would say maybe bowling on one side and something that we can like support weight on the other. And if we're lucky, we can actually get like a slack line going so I could crawl across, right? One person at a time, of course. We're not doing that.
Right. Okay, so what you're going to do is you're going to make a bridge.
Yeah, I'm going to make a... Oh, no, we're doing bridges?
We're doing bridges, buddy!
Yes. Oh, God, yes.
And more specifically, I'm glad you brought up the slack line because we are actually going to be talking about specifically suspension bridges right now.
Oh, yeah. You do not understand how happy this makes me. Oh, I love bridges. Oh, I can't
Bridges
wait.
are great. So bridges are great. And today we're going to be talking about the Broughton Suspension Bridge, which was built in 1826 to span the River Irwell between Broughton and Pendleton in England.
Okay.
1826? And this is 1826. This is actually one of the first suspension bridges that's built in England. It's one of the very early ones. This is still kind of in the early days of the Industrial Revolution. This is like the first Industrial Revolution. And suspension bridges were like all the latest rage. Oh, everybody was talking about them. It became like this really like popular attraction, I guess, of the local town.
You got to put your best suit on, your best hat. Because think about it, before these bridges, you were what, going to the dock and like waving your hat at a ship as it goes away. This is hype.
I mean, yeah, basically, like there was a ferry here at one point, and then they were like, "That's dumb. Let's build a bridge." And so this was a 144-foot long suspension bridge to cross the river. And basically, like it was a toll bridge. So if you wanted to cross the bridge, you had to pay to cross because it was a private citizen who built this bridge.
Oh, it wasn't like was this some dude?
It was just some rich guy. Yeah. So his name is John Fitzgerald.
Yes. Quite.
Yes. My bridges shall be the pinnacle of the local township.
I wet my feet every time I cross this river. No longer.
Exactly. I want to believe that really all that the all of the technological expansion in Britain was really just due to a bunch of wealthy people being mildly inconvenienced.
You would be surprised how true that probably is if you break it down to its butter. Like, what gets the ball rolling? It's usually rich guy, like, oh, I have the first car of the city. How am I going to get to Wrightendale? It's always something goofy.
Right, like now I got to build a bridge because I've got this car. Because,
Or so, I guess, can I ask a question before we start? You said as a private guy making a bridge, which I'm sure there's a reason we don't see that happening anymore. Is it like a rail bridge or just like pedestrian walking?
It's a pedestrian bridge. So I believe the width of it, it's not very wide. It's maybe, I don't know, I'd say maybe about 20 feet wide.
Okay.
From side to side. And then the walkway, it does have like a horse carriage passage thing on it. So you could take like a horse and carriage, but no, it's not a rail bridge. It's pretty small-ish.
Man, imagine taking your best gal with some ice cream over that in the 1800s.
I know, right?
That must have been the date of the century.
Did they even have ice cream at that time?
Right, because we were churning, right?
When was ice cream invented?
Folks were churning.
People were churning. Okay, so ice cream's origins are known to reach back as far as the 2nd century BC.
Oh.
Okay.
So as long as you have like cream, ice,
wow,
and salt, you're in business.
Yeah, I guess so, right? Because it's just salt and ice is how you make it that cold, and you just churn it, right?
Yeah, a little side piece for all of our friends of liking history. I didn't know that ice cream had been around that long. Me
neither. I mean, yeah, it's kind of wild. The first known instance of ice cream being served in Maryland is in 1744.
Oh, wow.
So ice cream, you could definitely have been walking across the Broughton Suspension Bridge with your girl and a scoop of ice cream.
Oh, wow.
At the time of its unfortunate collapse.
Uh-oh. Well, I don't know why I expected anything else. It was too good to be true. First you introduced bridges. Then it's just like,
it was too good to be true.
It's the origin of this bridge is just some guy.
It is. Well, okay, so let me keep telling you a little bit about this bridge. So this was, so these bridges were at the time were considered to be like one of the wonders of the industrial age. And the bridge was a suspension bridge, and this was made, I believe, with steel chains as opposed to cables, because at that time cables were harder to make than chain. And so basically, so it's an iron chain suspension bridge. And what that means basically is that you have to have these chains. Maybe I should back up a little bit more. So the way that a bridge
work?
How does a bridge work? Let's start there. So a bridge generally, right, is a structure that extends quite a long ways over a body of water or a chasm or whatever. And because of that, what you end up having is a relatively slender structure that has to support a weight in the middle of the bridge. And that is the combined, so there's a couple different types of weight that bridges can support. There's one that's called dead weight or static weight, and that's basically just the weight of the bridge itself. And then there's this also a dynamic weight or dynamic loading, which is basically going to be like all the foot traffic on the bridge or the train going across or the horses going across it and all this stuff, right? So a bridge not only has to support the weight of itself, but also the maximum loading or the maximum occupancy of whoever or whatever is going across the bridge. That's the basic premise of bridges. And so in order to do that, when you have a weight that is suspended out in the middle of an unsupported beam, basically, you're going to introduce bending into that beam. And so you can kind of simplify the bridge into a simple beam structure. And so when you put a force down in the center of a supported beam, a beam that's supported on its both extreme ends, what you end up having, obviously, is it will flex in the center, and the underside of the bridge will experience tension, and the upper side of the bridge will experience compression, right? Because if you think about this, right, yeah. So if you take your hands and you press them downward, you'll feel tension on the underside of your fingers, right? You're stretching your fingers out, and then obviously your knuckles are compressing on the top side.
So what you're telling me, Jim, and I cannot stress this enough, is that bridges are springs?
Bridges are enormous springs, and this actually leads to all kinds of problems. Right? Because the assumption is that bridges are really rigid structures.
Right.
But in fact, they are not, as we will see in just a moment.
It's such a simple thing you add. As someone who's not an engineer, I guess in my head I knew this, but I never considered the fact that you have to consider the weight of the bridge and support that first.
Yes.
And
then also everybody who's on it.
Right.
And
have some leeway.
And any other forces that may act on the bridge, which will become important later.
Foreshadowing.
Indeed. That'll probably be foreshadowed for another episode, but keep in mind, there are other forces besides just the weight of the bridge itself and the weight of the people or things crossing it that bridges have to contend with.
So we got static force, dynamic force, and some other thing that you're going to talk about.
Yeah, we'll talk about that. Let's just call those environmental factors for now, and we'll leave those for a later podcast episode.
Oh man, I'm so excited.
But to go back to the bridges, right? So if you kind of interlace your fingers and then press down on the centers of them, you'll feel that tension on the fingers, on the underside of your fingers, and the compression at the top of your fingers. So then the question becomes, okay, well, how do we prevent that deflection? How do we support the bridge in the center? Well, there's a lot of different options, as you can imagine. One would be to actually put in supports in the middle of the river, right? So you see these very old stone bridges, right, that have all these arches, and the arches are what supports the weight of the bridge and the weight of the people going across the bridge. And these arched bridges, these stone bridges, or they can be made out of metal and all other kinds of things, are generally like very strong, but they're also like very expensive to build and very time consuming to build. And sometimes you can't put them in because the span is just too great. And like the river is too deep to put in these pilings.
Oh, true.
And this kind of thing, right? So in that case, you are stuck with looking for something else. And that is kind of the problem that suspension bridges began to answer, right?
Okay, so you're being
a
able
su-
to distribute force from like less points of contact so you can go much farther.
Correct.
And also,
Correct.
yeah, that's interesting. I never even considered like when you go look at like a Roman bridge, right? Something very
Right.
simple. You can see
And
all of
so,
the like points of yeah, it's awesome.
yeah. So you got all the arches, which are all the points of stability. But on a suspension bridge, what you're actually doing basically is you're taking this bridge structure and you're putting up these pillars on either side of the bridge, and then you're tying cables across them, and those are stretched. Those cable, or in this case, chains. In the case of the Broughton Suspension Bridge, they're chains. Those chains are stretched. They're preloaded so that they are carrying a lot of tension. In this case, I believe in the case of the Broughton Bridge, it's like 2,000 tons of tension on these chains, just basically to hold the weight of the bridge. And basically what you're doing is you're preventing that bridge from sagging in the middle by having these cables that basically pull on the top of the bridge, and then they're connected to the span of the bridge by vertical cables that then transmit that load into the tension cables. And this creates a very cost-effective, lightweight, and relatively inexpensive way to transmit the tension, or the stress rather, in the center of the bridge out to the ends where it can be supported by pilings or piers that are closer to shore and therefore easier and cheaper to build.
Gotcha. Man, engineers are whoever thought of this, man. Holy cow.
Yeah, they really are fascinating feats of engineering and extremely incredible. But one of the problems with these types of structures is that inherently they are less rigid than trussed bridges or these stone bridge counterparts, because they are made with less material, which is both their strength and their weakness. So when they're not built properly, that can cause problems because there's less mass. And one of the things that tends to happen with springs of lower mass, which again, this is a bridge, which we've already established is a spring because everything is a spring. And now we've reduced the mass of the bridge quite a lot, from, say, like a stone bridge to now this suspension bridge. And one of the things that can happen with a spring is if you disturb it at constant intervals, right? So you think about like a pendulum, and you're hitting the pendulum at the right as it comes up to its apex, you hit it, and it starts going faster. And you hit it again, like pushing a kid on a swing to get them to go higher and higher. Mm-hmm. Springs exhibit the same behavior. It's called resonance. And all springs have what's called a resonant frequency. And what that means is that at a certain input of mechanical energy, the resonance of the spring, the amplitude of the deflection of the spring will become larger and larger and larger.
Oh, like it works off itself to power it more?
It
like adds
creates
energy
a
to the system?
Yes. So it creates a positive feedback loop that makes the deflection of the spring greater and greater and greater until either the loop is broken or until the spring fails or whatever, right? I hope you can see how this might be a problem in a suspension bridge.
I don't see how this could go wrong at all. What are you
well, let me tell you about the 12th of April, 1831, 6 years after the construction of the Broughton Suspension Bridge.
6 years they got away with it.
They got away with it for 6 years. So the 60th Rifle Corps was exercising under the command of Lieutenant Percy Fitzgerald, and a detachment of 74 men were returning to the barracks by way of the bridge, of the Broughton Suspension Bridge.
Oh man, 74 men with equipment.
So, yes. And these guys they're marching 4 people abreast, and they're all marching in step because this is the military and this is the 1830s. I'm sure you see where this is going. So as they're marching in step, the soldiers begin to feel the bridge vibrating. And basically they find this really funny, and so they exaggerate the step, and so they just keep hitting it, and they're marching a whistling tune, and they're having fun.
Oh man.
And basically, this bridge is swaying violently by the time they're all like kind of in the middle of the bridge. And then the head of the column had almost reached the other side of the bridge when they heard, quote, a sound resembling an irregular discharge of firearms. Immediately, one of the iron columns supporting the suspension bridge on the Broughton side, which is the side they were coming from, so most of the soldiers are past this at this point, collapses, and basically just dumps into the river.
Oh, God.
And so, yeah.
We should have seen it coming.
We should have. And so that side of the bridge immediately basically falls into the water. But the other side of the bridge, it's only on one side of the bridge that it fails.
They're okay.
Not really. Ooh. So basically, about 40 soldiers are thrown into the water or against the chains of the bridge.
Oh. God.
So yeah, that's not great. I guess fortunately, the river was pretty low and the water is only about 2 feet deep.
Is that fortunate?
Well, I don't know. Nobody died, which is good.
Okay, all right.
But 20 people were injured. 6 people suffered like severe injuries, broken legs and arms.
Dude, whoever hit the chain on the way down probably got the worst of it, you know? 2 feet of water ain't breaking no fall.
No, it is not breaking any fall. So it's 16 to 18 feet into the river. So that's a pretty hefty fall.
Yeah, and think about it. You're not just, a 225-pound man in the army. You have your rifle, your equipment.
Yeah, you've got your rifle, bayonet.
It's the 1800s. We don't have, light material.
Yeah. No, they're all... That actually maybe helps them, right? They're wearing these thick wool jackets and everything. It gives them a little bit of cushion.
Oh, that's fair.
But yeah, this is a serious incident.
But it's crazy that you say, because I would do the same thing. Even if I was a kid, if I was an adult, it's like a bridge go vibrating and we're all marching in step. You gotta put that extra sauce into the step. Hey, I'm going to get... It's just great.
Yeah, exactly. They're just having fun, right? And these guys don't understand the peril they're in.
It's probably the 6th time they've gone across this bridge for training,
Yeah, probably. So I think that there were other detachments that had returned to the barracks already, right? So what they, so this is a perfect example of this mechanical resonance. All these men marching in step are basically oscillating weights. They they're just adding in this little bit of vibration
and
into
them
the bridge
marching
with
in
every
step is like the cumulative
and there's 74
aspects.
of them.
Yeah.
It is. Yeah, there's 74 of these guys, 4 abreast, marching in step. Let's just say these guys are about 200 pounds with all their gear. That's like 16 tons of dude.
16
right?
tons of dudes stepping at the same time.
All just marching in step. And when people walk, if you actually look at videos of people walking, we sway side to side.
Oh, so you're adding another axis besides just down.
So it's not just up and down, it's also side to side. And so there's this kind of complex and very at the time, and even today, resonance is still one of these things where it's very difficult to actually accurately calculate the resonance of these very complicated structures like bridges. But yeah, this resonance problem is very hard to understand, especially given the engineering resources at the time. It was completely not studied at all, basically, at this point, especially considering these are some of the first suspension bridges that exist.
No, there's just some rich guy. There is no chance anyone's just like, hey, man, you got to make that out of X, Y, Z. They're just like, look, pretty.
Exactly, right? I think he did hire somebody to design the bridge, right? But that's not really covered very heavily. But basically, they go in, they look at this. Fortunately, nobody is killed. There are some people who are injured. And so they have to look at all this stuff. And they say, okay, well, what happened? Why did this happen? So they go and they investigate. They found a bolt in one of the stay chains, which is the chains that hold these. They're under immense force, right? They're under the immense tension.
I'm imagining this is a huge, big thickums chain.
Yeah, it is. So looking at the pictures, right? Obviously, these chains are probably as big. I'll have to share this picture with you, but the chains are probably as big as a person's wrist. They're big chains, and I can imagine that the bolts holding it into the stone piers are equally as large. I mean, these are big pieces of hardware. But they had found that one of these bolts that were holding the stay chains into the stonework had snapped.
Oh,
And
it just sheared off.
I think it pulled itself, right? Because this is in tension. And so so it either sheared off or snapped off. And it's important to note, like, the masonry was solid. The masonry is not what failed. It's the actual steel of the bolt that sheared.
Something else.
There's two things that they found. The one, that the bolt was badly forged. The metallurgy at the time is very different from it is today. At this point in time, any sort of like eyelets or even large bolts like this, right, have to be welded together. They have to be fire welded together, which is a whole different process to modern welding. And we can go over into that in a little bit. But the other thing that was heavily criticized was the design of the bridge had only one bolt anchoring the chains to the stone.
Oh no. So you got 1 point of failure for the whole bridge.
Yes, you have 1 point of failure for the whole bridge, and you have 4 of them.
Oh,
right?
Because you have not even. So if any one of the 4 goes, you're screwed.
If any one of the 4 goes, the whole thing comes down. Yeah.
Well, hey, you got to start somewhere. We started the 1800s. It's rough because this is one of those lessons you can't. They had no way of simulating this. You can make 100 models of this at different scales, but it's much easier to build a bolt that's smaller.
Absolutely. And so one of the things that they note was that there were several other bolts that were bent but not broken. So they come back to like the metallurgy, right, of the bolt being poorly forged. And at the time, let me explain to you a little bit about how steel was processed at the time. So in the 1800s, I believe the Bessemer process was not yet in widespread use.
For the listener, just note, this is conversation that me and Jim would probably be having anyway.
Okay, so the Bessemer process is not yet in effect, so we won't talk about that. So the way that steel is currently made is it's really made from wrought iron, and basically what that means is you have to take steel and it's put through a blast furnace, and you get the steel out the bottom, and it basically absorbs a bunch of carbon through the coal. So you have a layer of coal that's burning, and then a layer of iron ore that's crushed. And another layer of coal, and another layer of iron ore that's crushed, and so on and so forth. And effectively what you have is what's called bloomery steel. And this is done on an industrial basis at this point, but it's still like not a very great way of making steel. So basically you have to hammer the steel in order to drive out the impurities. And it's a very time-consuming process. It's a very expensive process. Because you basically just have to heat and weld the steel onto itself to drive out the impurities and to homogenize the steel. And one of the things that we've talked about a little bit is when metals have impurities in them, it significantly weakens the entire structure of the metal because it creates what's called a stress riser. And so a stress riser is a point in the metal which, if it was a homogeneous matrix, the stress would basically be flowed through and it would distribute itself evenly across the material. But if you have a little inclusion, in this case of slag or some other impurity, but in this case probably slag, which is just basically iron oxide that didn't get pushed out in the forging, it can create little sharp edges around the slag pocket. And as that steel is pulled, keep in mind, right, everything's a spring. And everything has a different spring rate. So that steel is going to expand and contract at one rate, basically, whereas the slag is not going to expand and contract at that same rate.
Oh,
and so that's going to create...
against each other.
They're fighting against each other. And so that's going to create basically a little pocket where the stress can accumulate, basically, because what you have is basically you have less material in that cross section of material that is actually going to be taking up that load. And so that is going to weaken the steel at that point faster than all of the other parts around it. And so over that cyclic loading, which is enhanced during this resonant period where the bridge is being pushed back and forth, right? You have this immense pulling on these chains and therefore on this bolt. Basically what happens is the steel at that point of that slag inclusion weakens to the point where it can no longer sustain the stress. It can no longer hold itself together because of the tension on the bolt or the shear. I'm not exactly sure which in this case. And it just snaps. And a lot of times in these types of stress concentrated areas where you have faulty materials, the failure can be extremely rapid because basically if you have lots of these little inclusions, what can happen is basically that crack can shoot from one inclusion to another. And so that can create a chain reaction where that little crack just and basically hits all these little nodes of impurity and then just rips apart the bolt or the piece of material. And so that is what they suspect happened at the Broughton Suspension Bridge.
It literally is the material science equivalent of one bad apple. Just one little piece of imperfection causes this great chain reaction. Because it's impossible to detect back then, right? Like now we have CT scans. You can look inside the material, at least some of them, right?
So one of the ways that steel
this?
is, you just have to do it, right? Like that's part of the problem, right? Is like progress so often is paid for in blood because you just don't know what you don't know. So now modern day, we can actually use ultrasonic testing basically to look inside the structure of the steel and detect cracks or flaws or whatever. And we can actually non-destructively identify bad hardware. And so a lot of modern civil engineering construction and stuff like that, all these bolts have to be ultrasonically tested in order to go into the bridge. And that's why they're so expensive.
Oh, that's just a part of the QA process now?
It can be. It
That's
can
cool.
be. Not always, but it can be.
Yeah, it depends, I guess, the grade, right? Of whatever.
Yes, and sometimes, and they also, there's a lot of different ways that people quality check their different parts and steels and stuff. And modern steels are made in a much different way. And so like the inclusions, it's very rare to find these types of slag inclusions in modern steels. It's almost unheard of, but it's still important to check, especially in these really highly critical fasteners like this one, right? And another thing that comes around as a part of this is that people are like, hey, maybe we shouldn't rely on just one bolt.
Right.
We should have, basically multiple...
Like sets of bolts that are redundant to each other.
Exactly. And in that way, if one of them were to begin to fail, the others would be able to take that load and prevent a catastrophic collapse as happened here.
Now, listener, if you're wondering the passion of which Jim just I would say, eloquently describes steel to someone who doesn't understand it, a little more chunk of your back life, if it's okay to talk about.
Yes,
in your spare time, you've worked as a blacksmith before you were an engineer.
Yeah, so to explain a little bit my fascination with metal, I have been a blacksmith since I was about 12. I've done forgings and stuff like this, and I've experienced, my mistakes at forging caused things to break. Fortunately, not to the detriment of anybody, but to my own knowledge, right? I've done a lot of research into material science as a result of that, and into steel specifically. And all these kind of old methods of making steel and forging things is kind of one of my passions. So
yeah, and it shows too, because like everything I know about construction and building things, at least things that are in my scope of what I can do as a single individual, probably learned it from Jim over the years, honestly.
You're very kind, Derek.
No, seriously, man. Like, you think I could do anything with an anvil? I didn't even know there are parts to an anvil before I met you. So yeah, like, it's interesting, even after you've done that for years since you were 12, then you go and get the engineering degree.
Yeah, and that like opened up a whole new world.
Right?
So one of my favorite classes in college was material science, where we took these different steels, like we took wrought iron and cast iron and mild steel and alloyed steels, and we actually cut them in half, right? And we polished them to a really, really high degree of polish and then etch them with acid. And then you put them under a microscope and you can actually look and you can see like the little slag inclusions in the wrought iron, and you can see the little pockets of carbide in the alloy steels, and you can see the different types of steel grain and hardened and unhardened steels. It's a really fascinating science.
God, I'd love to learn more about that. That's awesome.
Oh, it's super cool. We'll have to put up maybe some pictures of the of like different steel cross sections. I'll send you some pictures after we get done. So yeah, so one of the reasons that the bridge failed was the reliance on a single bolt to hold the stay cables in place. That was identified as a point of failure in the design. Okay. There was a second cause of failure that was identified, which was the brittleness and the material failure of the bolt itself. The bolt was not forged well and therefore failed.
So we got design, sourcing.
We have design, the material itself, and then finally we have the usage of the bridge. And that was basically that all the soldiers were walking in step and creating this resonant frequency, matching the frequency of the bridge that caused this growing oscillation until the strain on the bolt ripped it apart.
Think about how much of an outlier that is, right? Like 6 years of use, all the horses trotting across, rain, snow, shine, and this is what got it.
And this is what got it. And one of the things that happens because of this that's kind of infamous is that soldiers, when they go across bridges, are now ordered to break step. And so you see this on all kinds of different bridges in Europe. If you look on older bridges, there are sometimes signs that says, troops crossing must break step. And it's to avoid creating these oscillating and these feedback loops that cause the bridges to begin to oscillate.
Oh, so they just stop marching?
If they weren't marching in step in sync with each other, then because you got to think about all these different people are basically weights, and so if they're marching in step, they're swaying back and forth at the same time.
Like their combined forces,
and so their combined mass is additive, right? If you have them break step so that they're walking opposed to each other, would be perfect, right? Then the changes in the shifting mass of each soldier would cancel out with the person in front of them if they were walking in perfect opposite step.
God, so you really just, as a regular human living your life, you just want to try your best to never be the reason a new warning label's made. Because that's hilarious. I'm glad no one got hurt, but that's just one of those things.
No one got killed.
Who would think? Oh, yeah, that's true. No one got killed. Who would think about that until it happens, right?
Right. And that's one of these things, right? And so this actually breaks the trust of the public. Like a lot of people are like, oh, maybe we shouldn't build suspension bridges anymore because of this happened.
Oh,
right?
Gosh, what a different world that'd be.
I know, right? So it's kind of wild. But people do still continue to build suspension bridges because of their immense advantages and engineering versatility. But this is also not the only instance of a bridge collapse. And we'll talk about another suspension bridge collapse next week that was a very similar thing, but also had another factor. It's got that environmental factor that we'll talk about next week.
Man, you don't know how excited I am to, the tank failure series was awesome. I just had a good time learning about it. And I just kind of, after the series was over, I went through thinking of all of the tanks I work around and how little I knew about them. Besides what they teach you in the safety training. And it's just bridges is just one of those things. I don't know half as much as you. I wouldn't even say a quarter, but it's always intrigued me. I'm terrified of heights, but I'll go on a bridge to take a look. Bridges are truly fascinating. I mean, I love driving.
They're
over
marvels.
Bridges.
Yeah, they are truly marvels of engineering, and so awesome. But yeah, you really have to cross all your T's and dot all your I's when you're building these large infrastructure projects because people's lives are on the line.
Got to cross your I's.
Absolutely, got to cross your I's and dot your T's.
Man. Oh, I'm so excited for this miniseries because, I just can't imagine where we can go. There are bridges all around Europe, so many bridges in the United States, and when we think about post-Eisenhower area of making highways. So
I think what I'm going to do for now is we're going to focus specifically on suspension bridges, and then we'll go on to other types of bridges, maybe in a later miniseries.
Nice.
Because there's so many different types of bridges, and suspension bridges are really kind of very specific. And this actually I'm excited too, because this might actually give us an opportunity to talk about some of the engineering marvels of the world, like the Golden Gate Bridge.
We can get to the good stuff that works.
We can get to the stuff that works, right? And so we can talk maybe a little bit about the story of like how the Golden Gate Bridge came to be and some of the engineering challenges associated with it, and some of the really fascinating bits of history about it, and less about the disasters that may not have happened around it. So that'll be fun.
It's important to note, we can learn from both.
Absolutely.
That's the key. We can learn from both. Because I would love to talk about some positivity too.
Absolutely. And I think part of that too, right, is, the success of the Golden Gate Bridge is only possible because of the early failures of bridges like the Broughton Suspension Bridge, right. Where we're learning these lessons that then enable us to go further and is safer. And that's important to realize.
And then, if you just build enough bridges, eventually you'll go to space.
You must construct additional pylons.
We must construct additional pylons.
Jim,
awesome. Man, you don't know how excited I am to, I didn't really know where you were going with the mini-series. I guess because for the audience, we didn't plan to start a mini-series when we did episodes 1 through 4. It just kind of turned out that way. I'm really excited to have this kind of organizational structure so I can lock into an idea.
I think it makes it more coherent. So I'm excited to kind of experiment with that and see where it goes.
Yeah, but for reference, if you're listening to this episode first, right, you can just jump around our episodes for any specific subject. But if you look into the description, I'm going to put in brackets, whatever. If it is a part of a mini-series, because, in the future we might have episodes that are one-offs, right?
Yeah.
We'll have the name of the mini-series and what part it is. And I don't put end because we could always come back to another tank failure, for example. So yeah, keep an eye on that. If you're watching I think that goes out on all of our RSS feeds. So Spotify, Apple Music, Amazon, some other stuff I've never heard of, like Castbox. Have you heard of Castbox, Jim?
I have no idea what that is.
Somehow our RSS feed got on Castbox. I've now claimed it, but that's how we got our New Zealand listener.
Excellent.
From the other week. And I don't know if you noticed, I think I talked to you about it, but just on air, they actually wrote in on the YouTube channel or just yeah, that's me. Crazy.
That's awesome.
So
that's awesome.
If you're listening, person in New Zealand, vibing, walking your dog, listen to us talk about engineering, thank you so much for being our first international viewer. That's awesome.
That's awesome.
And we got one from the United Kingdom too.
We do have one. So we've gone international. Take that, big podcast.
Big podcast. They tried to shut us down.
They couldn't shut us down.
Up with water, down with air. Krusty Krab,
Derek,
unfair.
You got anything else to plug?
Besides us, of course, like always, if you want to get in touch with us, we have a lot of ways to do it now. If you're listening on Spotify, you can go use the poll tool there and leave us a comment or question there. On Twitter, we're at AllRSpring, ALLARE Spring. You can just give us some feedback. If you don't want to post it publicly, we don't really care about the publicity side. Feel free to send us a DM if that's more your style. And if I'm not mistaken, YouTube also has comment system. So if you're listening to this on YouTube, or even if you just want to drop by and drop a comment, we'll see that as well. But AllRSpring, maybe I'll add a picture of what the stickers you showed me look like. But they're not for sale yet. These are exclusive. We don't
know how to sell things right now.
Yeah. We haven't gotten that far yet, but maybe one day. Jim, do you have anything you need to plug? I think I can think of one thing.
Oh, I've got the Whiskey Grail. It's the white oak drinking vessel for all your bourbon, scotch, and rye whiskey drinking needs. It is made out of white oak and made to mimic the inside of a bourbon barrel. It's charred to enhance the flavor of the whiskey, bring out all those smoky and oaky notes, and help sequester some of the harshness of the alcohol. Perfect for once you get out of the river, bruised and battered after having fallen in on a faulty suspension bridge. It will soothe your woes.
It'll soothe your woes. It's a good
pick it up. Pick it up at www.whiskeygrail.com or find us on Instagram, TikTok, etc. at the Whiskey Grail.
Man, it's a great product, and I'm excited to have it as the first impromptu sponsor, because for reference, folks in the UK that have to do this is not a paid sponsorship. That is just, we love the product, Jim makes the product,
That's
our
true.
first
It's kind
official
of
sponsor, in
my
opinion.
thing. Absolutely.
Yeah.
Absolutely. Oh man. Well, Derek, I think we should bounce.
Well, Jim, let's bounce.
Let's bounce.